Last video cut me off a little early. I guess I was talking too long. We left off on lithium, right? Following the atomic numbers from 1 to 2, now to 3, and that third electron matches up into the 2s. Same thing for beryllium, 2s2 with 2 electrons. But then when we go from beryllium adding one more electron, now 5 total, look at atomic number of 5, now with boron we are in the 2p. And from boron to neon, we stay in the 2p because that p subshell can accommodate up to 1, 2, 3, 4, 5, 6 electrons. Okay? So if we were to look at something like, let's say, phosphorus, okay, it would be 1s2, 2s2, 2p6, then 3s2 to get to magnesium, and then 3p1, 2, 3 to finish on phosphorus. Okay? So that would be the configuration for phosphorus. 1s2, 2s2, 2p6, 3s2, 3p3. There's plenty of these to practice. A couple other things to look out for. Right? After calcium, notice we jump into, that's the first time we see the D block. Right? So what might be helpful is to kind of bold those lines all the way down so that it's clear when you're jumping from S to D or D back to P. And then over here, next to barium and radium, is when we first see ourselves jumping down into the F block. Okay? Now the F block won't be tested in Chem 1550, but the D block certainly will be. So for something like titanium, for example, we would be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, but then when I cross that line, now I'm in the D block. And remember, we had those new numbers over here. I'm specifically in the 3D. So the final ending to that electron configuration would be 3D12 to end at titanium. Okay. The two exceptions, okay, in group 6 and 11 here are because they pull an extra electron from the S block. Those are discussed in a separate video. Okay. One more for practice. Let's look at gallium. Okay, gallium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, now 4p1 is how I end gallium.